Okay, so this is the second data set, and this is one on restaurant reviews. Let's just have a quick look at the data set. Let's go all the way to R, and we can see basically that for each restaurant, we're rating each restaurant on ambivalence, cleanliness, service, and food. So, some online review websites give you a one rating like Amazon, but others like TripAdvisor allow you to rate the product on basically multiple dimensions. So this is what this set is. And you can see here that, there is a little bit of missing data. You see these gaps, there's some missing data here. So let's just like load it in exactly the same as before. We're loading in the library, then we're making sure we're setting the correct working directory. And let's just view. And you can see where there were spaces in Excel, we have these NAs. Now let's just use str, and as I think we did last time, str basically gives you variable information. You see everything here is numerical. And I've already been told it's 150 by 5, but let's just confirm this with dim. So 155 rows, 5 columns. So is.na, which we used in exercise 1, basically says if it's an NA, it's true. So if it's missing, it's true. Otherwise, it's false. We could also do it for a single column service. So we expect the second value here to be true. There we go. Now, how do we deal with missing data? So this is the purpose of the exercise. There's two ways. We can just say, okay, we're just going to ignore all of your missing data. Any row with any bit of missing data in, so let's go back to row 2, we're going to remove it. But, we have, say we remove row 2, we have useful ratings for ambivalence, cleanliness, and food, that we're just removing that data that's useful. So that's not always the best thing to do. But let's just say, okay, we're just going to remove, and particularly if you've got real world data sets with hundreds of different variables, if you've kind of removed that, if you remove a whole row because you're just missing one of those, then you are removing a lot of information. But let's just assume we've got a simple data set, and it's just the simplest thing to do, just to remove any row with missing data. And we're going to use a command called complete cases. Now, just as an aside, I just want to show you a little bit more about how to deal with, how to look up some command information yourself. If you type in help and the name of the command, you will actually get it in the help kind of tab in R. So I typed it. Another way of doing that, a shortcut which is exactly the same. Question mark to complete cases, and we get exactly the same. Another thing is that you could, if you've got a command in R you want to look up, or you're something you're not sure about, Google is actually your friend. If you go to R, just type in R, and then whatever command you want, and you'll actually, there's an R documentation site that summarizes most R functions, which tells you, give you an example of how to use it. There's also, if you look down a little bit, you can see stat.eth.ch. That's like a copy of the official documentation. And you see this is the same one that both of these are actually the same one that we got in RStudio. So that's a way of getting the official documentation. You can see there's all sorts of kind of tutorials here as well. So Google is definitely your friend in this class. And you see it goes through lots here, where this tutorial goes through lots of different scenarios. Anyway, that was a little aside. So we know complete cases basically just gets, what it does is, let's just show what it does, is it just kind of returns true. Let me just get complete cases, my data. It returns true if every variable is present, but in like row 2, where we had a missing service. If there's any item in the row missing, it returns false. And all we're doing here is remember I keep it talking about how when you're accessing data frames, you've got the square brackets, rows, comma, columns. We're basically binary variables here. Anything that's a true we return. We're returning all the data that only has true cases. So let's return this data. And you can see you go all the way down, and there's absolutely 0 NAs. So again, going back, complete.cases, basically any row that's a complete case. There's a blank with columns, so if there's a blank, we return everything, return every column. So it's returning the data set just for the rows with complete cases. And we can actually return the data set for rows without complete cases. Actually, that's to be confusing. Let's just call it AL cell data 2. And this gives the rows that don't have complete cases. Oh, I had view cell data. That's really why that didn't work. View cell data 2. We have 5 different rows where we have at least one piece of missing example. That was just me being too clever, changing the data on the fly so you can bring it together. And there we have it, the 5 rows with the missing data. Now, if you think that's all too complicated, and you just want a simple shortcut, if you want to, that's nice because it shows us it just gives you another examples of accessing data frames, which is one of the most important basic functions in R. But there is a function called na.admit, which just removes any rows with any NAs. So this actually does the same as this code. And you see here 145 rows, no NAs, which is the same as the previous. It's just a different way of doing it. Okay, so the second way of dealing with missing data is to find new values for the missing data. This is something called imputation. Now, we're going to do mean imputation. Now, it's the simplest way of doing it, and basically all we're doing here is we're replacing with the mean value. Again, this allows us to calculate, do calculations on it, do statistics where NA might blow up those particular calculations. Now, the mean isn't always the best value. Let's kind of go back to the original data, because generally, if people like things about a certain restaurant or hotel, then they tend to quite often like everything. You'll get a lot of people giving really high ratings on everything. A lot of people are just disgusted about their experience and give low ratings on everything. So quite often the mean, by just putting the average in, can be a little bit biased. But it's a reasonable estimate. We'll cover more advanced methods of dealing with missing data later in the course. But for the moment, we'll just subtract the mean. Now, to calculate the mean, there's a function called mean, and we just send in the vector of values. Do you see here? Each of these, we've got some NAs. This is the ambience and the service. What we're going to do is we're going to do mean. And we actually, with the mean function, we have something called na.remove equals true, which prevents the NA from messing the calculation up. So all this does, let's run that. And we have a mean for the ambience. We have, click that. And we have a mean for the service. Okay, so relatively simple. And now what we're doing here is basically saying in the ambience column, remember dollar selects a specific column of the data set. We're saying, and remember we don't need any commas here because we're just dealing with that single column. So it's just a list of numbers. And we're saying if any is.na of this column. So just to be careful here, this is the column. And is.not.na should have the same number of values of the column, but it's actually true or false. And we're going to set basically this column using these indicators, so where it's going to be true, we're going to set it to be the actual mean. We'll do this for both. Now let's just add a final line. And you'll see now that in those ambience and surveys, there's no NAs, but you can see, let's just find one of the replaced ones. Here we go. Here we go. For example, row 100, we've replaced the missing service value with the service mean. Okay, so, and we've actually done exactly the same on row 2. I kind of skipped that by for some way. So anyway, we've done two major things here. After playing around with the data set, we removed NAs either by just ignoring every row with an NA, or B, by just replacing those values with the mean for that column.